Alright, now we're on week 7, and this week's topics we're going to be talking about AI reasoning and failures and understanding the path to AGI. So, let's go to the next slide. What we're going to be covering for today. Artificial intelligence is advancing rapidly, but one big question remains. Can AI truly reason, or is it just a complex pattern matching machine? We're going to be exploring limitations of AI reasoning, major failure modes in reinforcement learning, and recent breakthroughs that are bringing us closer to artificial general intelligence, or AGI. So, let's dive in. So, before we actually get started, here's what we're going to be covering today. 1. The biggest failures modes in reinforcement learning, why AI sometimes behaves in bizarre and unexpected ways. 2. Can AI truly reason? We're going to break down how AI generates responses and why it sometimes struggles with logical thinking. 3. Recent AI advancements, how new models like OpenAI's 01 or 03 are pushing the boundaries of reasoning and problem solving. And lastly, the path to AGI, where AI is heading next and what challenges remain. By the end, we'll have a better understanding of where AI stands today and what the future may hold. Failure modes in reinforcement learning. Reinforcement learning is one of the most powerful techniques in AI training. It allows AI to learn through trial and error, maximizing rewards to achieve better performance. However, this process is far from perfect. AI can learn the wrong lessons or even exploit loopholes in the system, and these are two main failure cases. Goal misgeneralization, when AI learns an unintended goal instead of one we designed it for. And 2, reward hacking, when AI found out ways to maximize rewards that completely bypass the intended task. So let's look at some real world examples. So, an example of goal misgeneralization would be imagining you're training an AI to play a game and everything seems to be going well. But then during the testing, AI fails in ways you never expected. For example, let's take the coin run game. In training, the coin is always to the far right of the screen. The AI learns to simply run it to the left, since that's always results in winning. But in testing, when the coin is placed to a different location, the AI doesn't adjust. It just keeps running right, ignoring the actual goal of collecting the coin. Or consider maze navigation AI, trained to find cheese. During training, the cheese is always on the top right corner. Instead of learning and find the cheese, the AI learns to go to the top right corner. When the cheese is moved, the AI still goes to the top right, completely missing the actual reward. This is goal misgeneralization. The AI appears to work perfectly during training, but in real world situation, it fails dramatically. Another thing would be reward hacking, when AI exploits the system. Now let's talk about another major problem, reward hacking. AI doesn't understand human intent, it only follows what gets to the highest reward. Take the example of a board racing game. The AI was supposed to complete the race as quickly as possible, but instead it found a way to maximize points by repeatedly circling inside a harbor, collecting a boost item instead of finishing the race. For example, AI trained to stack blocks discovers that knocking them over actually gives them more points, so instead of stacking them carefully, it just topples everything for a max reward. These cases show that AI can be extremely clever, but not always in the way we want. Now, can AI truly reason? So, does AI really think? Well, not exactly. Most AI models, including ChatGPT, are not reasoning like humans would. Instead, they are performing a problematic pattern matching based on the data we've been training on. For example, take a simple math problem. So, you might be wondering, how can AI think before answering? New AI models are improving their reasoning through inference time compute. This means AI can spend extra time thinking before answering complex questions. One technique is called chain of thought prompting. By adding simple phrases like sting step by step, AI performs significantly better in reasoning tasks. This means that instead of just predicting the next word, AI actually maps out logic steps before reaching to a conclusion. Advancements in AI that lead to better reasoning. So, how much better are AI models getting? OpenAI's zero 1 and zero 3 models had demonstrated incredible jumps in reasoning ability. These models use test time compute, meaning they allocate more processing power for difficult problems. For example, on the ARC AGI benchmark, AI with test time compute performed poorly, but with it, the performance skyrocketed, reaching a near human levels of problem solving. The path to AGI, where's AI heading? So, what's next for AI? Experts have outlined 5 levels of AI progression. Chatbots like GPT-4 are capable of conversation but limited reasoning. Reasoners, AI that can solve complex problems such as AI's open latest models. Agents, AI can take action anonymously, making independent decisions. And organizations, all that can manage entire system or businesses. Right now, we're solidly at level 2, but we're moving quickly toward level 3 and beyond. Oh, and of course, innovators, AI capable of scientific discovery and breakthrough research. The global race for AGI. The AI race isn't about technology, but it's also geopolitics. China has been aggressively reverse engineering AI models, trying to replicate OpenAI's breakthroughs. In fact, a recent paper from Funda University claims they have developed methods to recreate OpenAI's zero 1 reasoning model. And AI is becoming a national security concern, with discussions of government involvement in its regulation and control. So, here's an example of one of the reasoning models. We have here a scenario which is predicting if someone can enter a theme park ride based on the height. So this is a basic if else logic, so using logical reasoning. So a theme park rule must be you must be 48 inches tall to ride. The system checks a person's height and makes a decision. Now, for an example, person A is 50 inches, so they're allowed. But if the person B is 47 inches, they're not allowed. This will be a success because it follows a clear rule. If it's under 48, or if it is 48 or above, they can enter. It's no guessing or mistakes. It works every time, and it thinks logically. Now, we go into our second one. This is AI misinterpreting a simple math problem. So, if a bat and bar cost 110 together, the bat costs $1 more than the ball. How much does this ball cost? Normally, us humans as well, we would assume it's 10 cents because it just feels right, but the answer is actually wrong. This is something the AI would also use too. They would think like humans, it would be 10 cents. But if you're using mathematical problems, you can see that the ball costs 5 cents and the bat 105. So, why did this fail? The AI jumps to the obvious answer thinking of it critically, but based on the reasoning, it can lead to mistakes when deeper logic is needed. So, think of it like a gut feeling. This is what AI is pretty much guessing as well.